solving systems by elimination. Let's open this flap. One thing up here I want us to kind of note with a little star note. Okay, what's it mean when you eliminate something? Yeah, you get rid of it. Okay, so eliminating means to get rid of one variable. So we're trying to get rid of one of our variables, either our x's or our y's. And so another word that's been a while, well, I mean, I say it on a regular basis, but you may listen, you may kind of tune me out on that. It's called a zero pair. Okay, a zero pair is kind of what we're trying to make with one set of our variables. So a zero pair, make a zero pair with either the x's or the y's. That's what we're looking to do, and then we're going to add. And when we add up zero pairs, they get rid of each other. Zero pairs make zero, and so that's how you eliminate or get rid of one of your variables. Okay, so let's look down at the bottom at the examples that I've already got written down here. If I am eliminating, here's how we set these up. Notice that they're in standard form somewhat. Standard form is ax plus by equals c. And so normally in graphing they're in slope-intercept form, okay, for point slope. So this is kind of how we set these up. They look kind of different. But your x's need to be above your x's, y's need to be above your y's, and then your constant, or your, not your constant, but your, well, yeah, it is, your answers. So let's look. If I were to add straight down my column, straight down each one of my columns, okay, would I be getting rid of or making a zero pair with either my x's or my y's?
Your x's.
Your x's, because look, you have a positive 3x and you have a negative 3x. That's what you always want. Okay, you want to be able to eliminate either the x's or the y's, it doesn't matter. Okay, so this problem is already, and the ones you're going to see today are kind of already set up for that. You just have to see the zero pair. So if I'm adding down the columns, this one doesn't have a coefficient. What can I put in there?
1.
A 1. If you like to put ones in there, it's fine. If not, you don't have to. So if I'm adding down my columns, 1y and 2y make 3y's. And then you just told me that this makes 0, which is what you want, because you want to eliminate. So we eliminated our x's, which is a good thing. And now a negative 2 plus a 14 would be a 12. Now this turns into a nice one-step equation. I know that there's some blank space there, but that's because I added up and made 0. But my problem really is 3y equals 12. So how do you solve that? Yeah, divide by 3 on both sides. So y equals a 4. Now, is that your whole answer or only half your answer? We're back to getting only half of our answer. We didn't do that much work, though, really, to get half of the answer. We know now that y is a 4. We're looking for an ordered pair of where these lines, if I graph them, where they would cross. Okay. So if I know that y is a 4, you pick either one of these. You can choose to substitute the 4 back in and solve for the x. Do you think the top one looks easiest or the bottom one? I feel like the top one does, but it doesn't matter really. You know, you can choose either one. So let's just choose the top one. So if I take the 4, and I'm going to substitute it back in right there, I'm just going to kind of draw that arrow. I'm going to write it up here. 1 times y, well, if y is 4, what's that going to turn into? 4. Plus 3x's equals a negative 2. That's what your problem turned into after you substituted the 4 back in for the y value. Because 1 times 4, that's how I got that 4. Now to solve this equation, how do you get rid of that 4? It's positive 4. Yep, subtract the 4. Do that on both sides. So I have 3x's equals, be careful, a negative 2 minus 4 is a negative 6, negative 6.
Oh.
If it was, yeah, you gotta watch your signs on that. And then divide by 3. So x equals, what kind of 2? Negative 2. There's your other piece. So the ordered pair for this example is negative 2 comma 4. And that's elimination. Still a lot of work. It's doable. It's just a little different. You still use substitution in this because you have to substitute your answer back in. Let's look at the next example below. When you set this up, which variable are you going to be eliminating by looking at this?
Y.
You're going to be eliminating the y, because look at the y's. You have a negative 2y and a positive 2y, and that makes a 0 pair. That makes nothing. So that's good. So let's put our plus sign, because all day today you're going to be adding to eliminate. Again, there is no variable. I'm sorry, no coefficient there on that variable. So you can put a 1 in there. So that's going to be 6 x's. That makes nothing, so that's good. They cross out or eliminate each other. And negative 19 plus 1, negative 18. And then divide by 6. X would be a negative 3. So x is a negative 3. Just sit right here. So now that you know that x is a negative 3, you can substitute that back in either problem. Let's sub it in the bottom one just because we subbed it in the top one last time, okay? So if x is a negative 3, I'm going to put it right up here in that problem. X is a negative 3. So what's that make this right here? 5 times the negative 3 is negative 15. I'm going to write it kind of sideways here. Negative 15 plus, negative 15 plus 2y equals 1. There's what your problem looks like when you sub that back in. So always get rid of your constant first. It says a negative 15. So to get rid of that, to make a 0 pair with that, you have to match it up with a positive 15, right? Or add 15 to both sides. So then your problem reads 2y equals 16. And then to break the 2 and y apart, you would divide by 2. So y equals 8. So now you know this order pair is negative 3, 8. How many people feel like you could probably do this on your own? How many at least feel like you can get at least half of it right? Okay? So, I mean, half of it's better than none, right? Okay, because yesterday on our quiz, if you noticed, some of the problems you didn't even have to work out. If you knew it told you half the answer, you just had to choose the order pair that had that one piece in there. If you noticed that, I don't know, some of you may have. If you'll take this and flip it to the back of this side right here, there are 2 little you try problems. Okay, if we look at the very first one, what are you going to be eliminating, the x's or the y's? And this one right here, it's going to be the y's because, the x's. A negative x plus a positive x. And if you don't have numbers, remember you can put in 1. So you have a negative 1 and a positive 1. So you're going to get rid of the x's in that one. So go ahead and add. You're going to add down each column, just like we did in the front. Add straight down. Watch your signs. If there are no numbers, put in 1. So if you add straight down, you should have gotten 0 there, or nothing. And then negative 4y equals a negative 4. To break them apart, you need to divide them. And y would be a positive 1. That's only half of your answer. So now you pick one of these, either one that you want, to substitute the y is 1 back into. I'm going to choose the top one. You can choose whichever one you want. Negative 1x plus 1y equals 5. It said that the y was a 1, so I need to sub in a 1 right there. So now my problem would read negative 1x plus 1, because 1 times 1 is 1, equals 5. And then I solve it. I gotta get rid of this piece first. So take away 1. Negative 1x equals 4. And then divide by negative 1. So x is negative 4. So your ordered pair is negative 4, comma 1. And then try number 2. If there are no numbers or coefficients, make them 1s. That's not 1 that's 14 plus 12 plus 2. Both of those are positive. Yep, everything we do, they adding, you just gotta watch your signs. So this one turns into 2x equals 14, and then divide by 2, and x would be 7, so that's one piece of your answer.
I'm supposed to go downstairs, so I'm going to filter.
Okay,
So,
they may already be gone, but hustle.
did you know, I thought they were gonna call us down?
Well, is it with the,
He said right
Yeah,
after
yeah.
announcements to go.
yeah, hustle down and see, hopefully they've not left yet. Okay, plug back in a 7 for either one. I'm gonna go with the top one. So 1x plus 1y equals 12. If x is a 7, there's what that looks like. And then multiply that out. 1 times 7 will be 7. Plus 1y equals 12. And then get rid of the 7. That's the first number you get rid of is your constant in that problem. So 1y, which there it is 12 minus 7, which is 5. So your order pair is 7, comma 5. Okay, so we're going to try a few of these. And all of them are already set up so that you can eliminate either the x's or the y's. Tomorrow, I'm going to have some problems where we have to fix them before we can eliminate, okay? So it does get a step harder than what we just saw, okay?